Hello and welcome to a complete waste of time. If you have anything important to do, you might want to do that instead, but if you want to learn about software engineering practices, they're probably talking about it somewhere else. Here, I'm going to talk about practical best practices today. In particular, this is a practical guide for practicing software practitioners of software development practices. I am, of course, Chet Haase. I'm a well-known process methodologist. More importantly, I have the following titles in my company. And of course, I'm a senior VP of that division. This is for the company. I want to tell you a little bit about the company that we run. It's Process Methodology Strategists, or PMS. We focus on methodologies and processes for improving software and company effectiveness and for providing effective billing transactions between clients and PMS. I want to talk a little bit about some of the services that we offer. We will offer a wide range of services to our clients, from consulting to management consulting. Also management consulting management, and consulting management. The prices obviously span a wide range. I realize that these prices don't really apply to most of the people in this room, but I wanted to say today, for the first time, that we also offer pricing in euros. If the service that you're looking for doesn't apply to the exact services that we have on the slide, please have a conversation with me. I have a reasonable billing rate for telling you what the rate will be for the project that you're actually proposing. Now let's get into the talk. Someone said a long time ago that practice makes perfect. I don't know who said it, and it doesn't matter because it wasn't me. What I like to say instead is that practices make perfection. I like to say this because I think it applies to this talk and because it's my quote. I like to back this up with a little bit of data because I understand that clients may be wary. They want to understand why I'm making these insubstantiated claims, and I'm here to tell you they are substantiated. Let's look at a little bit of data on practice. Now, you can see, this is data taken directly from a client, that they practiced throughout a year, and they achieved more and more perfection during that year. This is hard data. Those are numbers behind that blue line that you see on the graph. I want to talk about another quote that I think is even more germane to the topic today. It's that practicing practical software development practices makes more perfect software development practices. Let me boil this down for you. This means it's not important enough to simply practice. It's important to practice software development practices. Let's look at some more data for this. Now, here's a client that spent the entire year, except for the month of March when they were on an offsite, practicing software development practices. And as long as they were practicing these practices, they were achieving 100% perfection in practicing software development practices. That is key. If there is one takeaway from this talk, it's my business card so that you can call me and hire my company. If there's a second takeaway, it's the data behind this slide. Practice software development practices. Now, having covered that, obviously software development practices are important. There are several in use throughout the world. Today, I wanted to talk about some of those as well as some new practices that I propose for making even better quality software. So let's go over some of the traditional ones. First of all, let's start with code comments. I think this is obvious to everybody in the room. You want to make more maintainable code. You also want to be able to come back to that code later and understand what happened. So here we have an example. So it's a simple getter. We're getting a calculation result. It's returning the value of an internal field. So that's all fine. Maybe you think it's self-explanatory, but it's not, because there are not comments there. We don't know what calc result refers to. We don't know what valid arguments are, what valid return values are, what error conditions might occur. So we need to add some comments so that future maintainers, including ourselves, will understand what's going on. First of all, it's important to add some implementation details in there. So what is it that calc result is? What does this field refer to? Under what conditions would you like to return it? What would you like to tell yourself about this code, your future self, so that you understand what's going on in here? Secondly, there may be bugs that come in So, for instance, I wrote this code, and then months later I discovered there was an off by 1 error. Well, when you fix the code, it's important to make a note of that because you want to keep people in the future from making that same bug. So just make a little maintenance note in there. That's fine. And then I came in a few months after that and realized there was actually an off by 2 error. So, of course, I needed to add a note about that so that I understood that. A few months after that, I realized, no, I was actually right the first time around. It was an off by 1 error, and now everything was off by -1. But again, we just make ongoing notes so that the next time I come back, I understand what's going on in the code, and I can try to avoid making the same error in the future. Now, you're going to need some attributions. Most importantly, you're going to want to tell people who wrote the code so that they can hire your company in the future. You're also going to want to tell people what might actually relate to this. You want to refer them to other classes or other technologies or Wikipedia entries, maybe your Google Plus account, anywhere that they might get more information on this important calculation and important getter facility. So you want to tell people about the math utilities. You want to tell people what a calculation is. Anything that you can think of that might relate to the topic. Terribly crucial because they need to understand what's going on in the code at all times. Now, of course, something like this might easily throw some exceptions. So you want to be able to return the exceptions, and you want to tell the users important information about what those exceptions might be. There are return values, of course. In this case, we're returning a float. Well, what kind of float? What are valid values here? What should they expect? Is a -1 important? Is 0 important? How about not a number? I don't know. Well, I do if I have header comments in there, right? So add the comments, tell the people what's really going in there. And then finally, we have the header comments that actually describes what's going on in this complex function. In this case, we're going to be returning the value indicates, whatever is important information so that they fully understand the scope of what's going on in the code. And then one final thing is you're probably going to want the method name at the top because it sort of got lost in all the noise. Naming conventions, obviously really important. So we need things to be clear, we need your code to be maintainable, and we need obviousness. We need to look at the code and understand immediately what is going on in that code. So I wanted to show an example of code that we wrote for a client recently that demonstrates this principle. So in this case, we have a method called Chet #1, which I prefer method names like this because it's clear that this is the first method that I wrote on that day, or possibly in that class, I can't remember now. I use all caps when talking about methods that I wrote because I'm using my name and I just want to call attention to it there. It's important to use punctuation in your syntax to indicate other metadata about variables. So for instance, right here, we're passing in an X parameter. Well, that X parameter is really important. I want people to know that. So use an exclamation point. Call attention to that detail that people need to know. All right? What about the Y parameter? I never really understood why we were passing that in to begin with, so there's a question mark there. I don't really know what's going on there. That's important for them to know as well. This variable name I find really important because who does really know what's going on? We're dividing through by a value that I didn't understand to begin with. So again, question mark. Who knows? And the naming convention. Who does know? Not me. And then finally, we call into another method. This was the 7th method that I wrote on that day. Actually, it was the 8th method that I wrote, but then I deleted the 7th method so that I renamed it appropriately. Refactoring is so important in the code that we write. And then we're passing in, obviously, this who knows parameter. Still don't know what's going on there, question mark important. And then right. And this is a Boolean value that we use an exclamation point for, saying, yep, I know that that's true. Or I know that it's false. I know something about it. Or at least I did when I wrote the code. The important thing to note is that this actually won't build and compile and run in any known runtime or compiler technology that I'm aware of. Which is why we wrote one for the client as part of writing this code. This enabled a very high standard of living for all the consultants on that project for quite a long time. Simplicity is very important in code. You want your code to be easier to write and also to read. And in fact, You want your code to be fun. I think that writing is fun. It's fun to consume and it's also fun to produce it. And code should be the same way. Here's an example of some code that we wrote for a client where we talk about Bob and Marianne and they're going to the store. Now one thing I'd like to point out is we use go-tos all over the place, but I find it makes less maintainable code if it jumps to somewhere else in the code. Instead, we tend to just go to the next line. I think that's very obvious, don't you? Right, so we're going to go to the store, and the store is right there. There, I can see the store. It's very obvious. There's no problem with this go-to statement. Who shot Bob? I don't know. And then this little 0:0, that's actually just for effect. Right? I like the syntax of that. I like the way it sort of jumps out at you at the page. It's sort of a funny symbol. So we're going to ask a question, and then we're going to determine who the culprit was. It was, of course, Marianne, because that's his wife. Who wouldn't kill Bob if she was married to him? And then why Marianne? Again, fun little syntax there to sort of emphasize the point. This code, again, required a custom system and runtime, resulted in a fantastic contract that went on until the company went out of business. You want your code to be portable and maintainable for several reasons. There's diverse platforms in the world today, and these are changing over time. Other types of platforms, other form factors are coming online, and you want to be able to write code that works everywhere eventually, right? You don't want to rewrite that same custom logic in new platforms and new languages, and you want to be able to port it and move it across different systems as much as possible. So here's an example of doing that. So we wrote this again for another client. This is representative of, I think, what is probably the best basic program in the world. You will, of course, print that word infinitely all over the screen, which I think is hilarious. We didn't actually have a basic interpreter or compiler or runtime on the system, so we had to write one. And then we would evaluate each statement. I like the eval statement from JavaScript. I think it's very powerful to be able to take arbitrary strings and run basic code. It's just something I like. So we wrote a system to do that, and it works very well. And we could then port this system to all of those systems that we wrote that compiler and runtime for. Which unfortunately didn't extend as far as the Pentium. We have a beta version running on the 486, and it rocks on the IBM 360. Continuous integration, very important. You want to build your code, you want to test, and then you want to repeat it. The most important thing to take away from this is that such a system is obviously going to require a lot of storage, a lot of servers, and a lot of bandwidth. And the important thing for you to realize there is that this means larger IT budgets leading to huge consulting contracts. Huge. So you can provide services for your client that span the breadth of consulting on software to actually building entire IT infrastructures just because of continuous integration. So I think all consultants in the room should really take away this point as well as my business card. Testing, very important. If you have tests, you have confidence in the code. If you have more tests, you have more confidence. And here's the important point. Even more tests, even more confidence. All right? So let's talk about tests. Let's talk about what you can do to provide more tests. And let's talk about some data that backs up this assumption that I'm throwing out at you. So here we see an increasing number of tests leading to an increasing amount of confidence from the customer. This is based on data that we abstracted from something at a client site sometime in the past. So obviously huge, right? So here's an example of a test framework that we wrote. We wrote a test that called into a method. That's very powerful. I want to make sure that I can call it with certain parameters, that it returns, it does the right thing with those parameters, that it doesn't crash, whatever. I need to make sure that if I call that several times, in different ways, that it's always going to keep working. So I'm going to write different variations of that same exact test over and over and over again. So all of those are really powerful, but it gets a bit tedious to manage all of these tests that you wrote to test this one single method. So then you're, of course, going to want to run it in a loop. It makes it a little bit easier. And just run this thing over and over and over again, getting a little bit tedious and unwieldy here. So you're going to need a test framework. Right? And then you're going to have other methods, not just this one method. Let's not be silly here. You're going to want to test all the methods in the module. So you're going to need another test framework for all of those that you're running in a loop, and on and on and on. Very powerful system. Most importantly, you're going to get a lot of these test frameworks that you then have to deal with, so you're going to need a framework for that framework. And then you're going to need all of these for all the modules in your system, and then you're going to need a framework for that as well. This can just spiral completely out of control until your client runs out of money. So huge win for consultants here. Let's have a chat about process. I think everybody that knows me knows that I'm heavily into process. You may know me from such videos as Pattern Schmatterns and Crystal Methodology, the future of software process methodology effectiveness. What I think everybody knows, sort of the obvious point, is that process is a dependable routine for developing, testing, packaging, and shipping the product. But the less obvious point is that process requires many, many more people in billable hours. Many more. And that's really the takeaway for everybody in the room that wants to make more money from their clients. Let's take a break here and let's talk about software quality. It's so important. So I'd like to take a look at some of the driving factors in software quality today. So I have a law that I created called the first law of software quality, and it goes like this. The more code that is written, the more bugs there are. And you can quote me on that because it's my quote. I can also rewrite this as follows. The number of errors equals the amount of more code squared. It's slightly awkward, but it's more conveniently written like this. Just calls out to you, doesn't it? It looks very familiar. You glom onto it immediately. I have a second law of software quality that goes like this. The more bugs there are, the less quality that software has. Again, you can quote me on it, and I'll bill you later. So let's take a look at an example of that. This is taking a look at some code that was written for a client site here. We have this file in which we have a certain amount of code. There's fields, there's comments, there's methods. There's not nearly enough comments for my taste, but there are some in there. And then let's take a look at a second file in which we have nothing. So let's take a look at the level of quality in these files. First of all, let's look at the number of bugs that each one of these has. The one on the left, probably more than 0, right? There's a solid chance that there are bugs in this code simply because the code is there. The one on the right, 0, guaranteed, every time. Every time you write an empty file, there are no bugs in that file. Let's take a look at the quality metric, not just the number of bugs, but the overall quality metric. I would say that because of the number of bugs in the file on the left, you have worse quality, whereas the file on the right has the best quality of these two. Now, we can use some graphics to represent this information as well, like this. And I think that's pretty obvious there. So here's some more data to take a look at. So the amount of code that this client wrote increased, and the number of bugs that the client had increased as well. All right? There's another way to look at this. If we flip the data around, it looks like this. We can take another look at the data, and we can use some three-dimensional charting information to produce data that looks more like this. And you can see it's the same information over and over and over again. The number of bugs increases, the number of lines of codes. I'm not sure I wrote this right. The amount of code that you write increases the amount of bugs. I think that's the important takeaway here. And we can take another look at it, and it's still the same over and over again. Higher bugs, lower quality, more code. Okay, so I believe that the path to better quality software can be had like this. If you want higher quality software, you want to create fewer bugs, and if you want to write fewer bugs, you need to write less code. So let's take a look at some important software development practices for achieving that goal. So first of all, let's take a look at hiring. The number of programmers that work for you increases the amount of code. I think that's pretty clear, right? What's not as obvious is the number of non-programmers increases the amount of quality, right? The less people those code are writing, if those people write less, the less code, they're not going to write much code. That's what I'm trying to say, all right? They're not programming. That's why you hired them, to not program. So let's look at what you need to do in your hiring practices to achieve the higher quality. First of all, you want to hire fewer programmers. Second of all, you want to hire more consultants, managers, program managers, product managers, HR, facilities, baristas, whatever it takes to get programmers in the door non-programmers in the door to not write code for you. Managers are important because they have the budget to hire consultants. Consultants are important because they're going to streamline your business effectiveness and occasionally take you out to lunch. Program managers, they're going to keep their eye on the schedule, and that's what's important to the client. And product managers, they're important because they're going to get the requirements from the customer, and then they're going to go back to the customer and tell them what it was they wanted. Huge. But none of that stuff produced code, and none of it, more importantly, produced bugs. All right, so another important best practice is resting. I like REST services. The amount of time you spend programming increases the amount of code that you're producing, which again increases the number of bugs and lowers the software quality. So there's various approaches that you can use to REST services. I prefer spending more time in the restroom. You can relax in the stall. I find it very hard to book conference rooms sometimes, so why not just go in there and close the door and just hang out for a while. You can play some games in there. And just make sure you come out before lunch, because the lines get really long at lunch. And you're not writing code during lunch, so that's a freebie. Right? There's important productivity tools that can help you in achieving this goal. First of all, multiple large monitors. I find it very helpful to be able to play a full screen video on this one while I'm playing a game on this one. Right? If you're stuck with small monitors, you may just end up writing code because the full screen video experience is so unpleasant. You want to provide your developers and your employees the fastest machines available, because you wouldn't want to do something like have the performance of the video take down the performance of the game that you're playing. You want a solid keyboard, and there's a particular kind of keyboard you want to go for here. There are some keyboards that make almost no sound at all as you type the keys. That's not the kind you want. You want one of those clicky-clacky keyboards that make so much noise that all of your office mates ask you to stop typing. Very important. And finally, noise-canceling headphones, because you want to eliminate the office hum and actually enjoy that full-screen game experience. There's several metrics of coding style that you should pay attention to. First of all, you want it to be consistent so that you remember what it was you actually did 2 months ago. Secondly, you want it to be readable, right? You want comments, as we talked about already, and you want to have an appropriate line length. A lot of people go for a standard of 100. The traditional line length was 80 back when monitors were much smaller. I like to go for 20 or maybe even 10. The length of your line determines the number of lines of code that you're going to have in your file, but it also determines the density of logic in there. So you're going to have fewer bugs per line of code if you can just increase the number of lines of code without changing the core amount of logic in your file. And finally, blank lines, along similar lines. Just make it more readable, space it out, and bill your client per line of code. And I think you'll see that blank lines will work out for you in the end. I created some charts around here because I think data is so important. So here's one. So the number of lines of code decreases the quality, right? The amount of logic that you have in there decreases the code quality. I think that's pretty obvious. The number of comments, however, increases it. So if you can inject more and more comments in per line of code, you're by definition creating higher software quality. Except, and I think this is an important point, for the comment systems like JavaDocs that allow you to inject logic into the comments themselves. Right? How many people have broken the build by doing some parameter tag that was incorrect in JavaDocs? I know I have, and I've billed my customers for a lot of it. So that's why it's important to not use JavaDocs, but just to use plain old comments, because there's no logic there and no chance of writing any actual code logic. Finally, I'd like to talk about line lengths. And this graph I find very interesting because there's a curve in it. As you can see, it starts at a very high value and then drastically drops. So basically, if you start at a line length of 0, you've achieved perfect quality because no logic is in that file at all. And as soon as you start writing any code whatsoever, then your quality drops drastically. So just keep an eye on that curve. and appreciate the quality with which this graph was done. Finally, we can overlay a couple of factors and start seeing how they relate to each other. We've got line length, and we've got the number of blank lines in your file and how they contribute together to create the lines of code, as well as the density of logic in your file, as well as the overall quality. And this leads toward my final data that I'd like to put up today, where we combine these factors and several others to come up with this self-explanatory graph. I think that's obvious. I can pause for a second. Yeah, I think that'll do it. All right, so finally, I want to ask everybody in here today to practice best practices. Thank you. I never know how long these things are going to go on, and this one's over now, which means that I have time for questions if anybody has some. Yes?
I'm really surprised you didn't put the full license at the top of the method you showed at the beginning.
The question was, why didn't I put the full license at the top of the file? And that is excellent out-of-the-box thinking, and I'd like to ask you to send me your resume. Unless... do you write code or just licenses? Okay, we'll talk. Anyone else?
Are you billing this year more? Because last year you were without a tie.
Question was, am I billing more for this year because I am wearing a tie? Stefan's going to find out later. Yeah. I really went all out for this year's presentation. Yes? Let me see if I can repeat that. There was the word monetize, and there was practice said several times, and that's about all I got. I'm going to go out on a limb here and say yes. Thank you. Excellent question. Excellent. Anyone else? Yes. Am I going to write a sequel to Filthy Rich Clients? That was someone else. It's not me. People often confuse me with the author of Filthy Rich Clients. Were I to write a book, I think I'd have to see far more money in it than that person did. Good question. If I could bill a client for writing a book, I think that could work out very well. Yeah. Yes. Does what help the practical? Commenting out the code is an excellent approach. That's actually one of the best ways to maintain someone else's code. When you go into the file later and you find far too much logic in there, absolutely, just insert comments. It's one of my favorite things in modern IDEs is the ability to select a whole file and comment out the whole thing. Yep. Not only does it remove the logic and increase the software quality of the entire module, but it also allows you to check in a diff that shows that you wrote a lot of lines of code that day, which you can directly bill the customer for. Yep. Yes?
What about annotations?
What about annotations? There's a little bit of logic involved with them, so you have to be careful with them. What I prefer to do is put them behind comments, as if to say, I would have annotated this, except I didn't want to break the code. Yes?
What about pull requests and comments on pull requests?
What about pull requests and comments on pull requests? I would love to answer that question if I had any idea what you were talking about. I'll get back to you. Maybe you can hire my company and we can go investigate the topic. Appreciate it. I think we're at an end. Thank you very much.